Okay. I'm Vidar. I'm going to talk about how we integrated OData into Webnodes CMS. The agenda for the talk will be some background information about the CMS itself, to give you some understanding of why we made the choices we made, the goals for the implementation, the challenges we had, the solution we ended up with, the experiences we've had with OData so far, and also some future plans we have with regards to OData. Webnodes is a software company based in Oslo, Norway. We're the company behind Webnodes CMS, Semantic CMS. It's a .NET-based solution, and you can find out more information on webnodes.com. Webnodes CMS is built on top of a specialized ORM, written in-house, and it's specialized in the sense that it has built-in language and revision support and so on, and other CMS-related features. So it's not just a plain ORM. All data access in the system is strongly typed, and we use code generation heavily in the system. All data access uses the API, and the CMS itself is actually built on top of the API, so it's just like any normal application. We also have a semantic focus, and that means we want to bring in the benefits of semantic technology to the content management space. And I'll talk more about that later. We have really intelligent cache in the system, because everything goes through the API. We can easily find out when a certain database operation affects the cache. So the cache is almost always up to date. So most pages don't even touch the database in our system. We use a custom link provider. We use the Relink project, if anyone is familiar with that. That simplifies writing a link provider quite a bit. We have very flexible data modeling capabilities in the system. I'm not sure how familiar you are with CMS systems in general, but normally you have a tree structure and you have pages. But in our system, you can model any type of data. So it's really freeform, and you can use it for much more than just regular websites. So we're more like a CMS application framework, and we think that's the way that the web is moving. It's not just about publishing pages anymore. It's more that websites are becoming web applications themselves. You have more and more advanced functionality on all websites. So to give you a brief overview of how OData fits into our solution, you of course can produce HTML pages that you can view in browsers. But we also have, but since we have a semantic database at the core of the system, we can also add semantic tagging to the HTML. That opens up for semantic searches using schema.org, if that has been mentioned earlier today. Schema.org is based on market data in HTML5, and it makes it possible for the search engines to basically understand the HTML in the page. In addition to producing HTML, we also can have data endpoints on top of the API. OData is what I'm going to talk to you about today, but we'll also be coming out with the Sparkle endpoint later in a couple of months. So by having data endpoints on top of a CMS, we can expose the content in the CMS to mobiles and tablets and so on, or any other application. So to do integrations, for example, it's really good. And it's also really nice that you have a two-way communication channel, and you can then, of course, update the content in the database based on the OData endpoint. So this is how we see our solution. To give you a bit more understanding of how the data model is created, I'm going to briefly show you that in the system. because this affects how we solve OData. Okay, the demos I'm going to show you today is based on a demo site, so it's not real data, but this is something you can install when you install our software. So I'm going to log in as a master user that has access to enable OData, for example. The ontology module is where you define the data model in the system. What you see here are the content classes or document types, or what you want to call them, that are basically the classes in the system. For example, location has these properties in addition to the ones it inherits from the other parent classes. And based on this definition, the system generates an object model on disk. So if you go to Visual Studio and take a look at the example site, you can see you have namespaces here, and here you see all the generated classes of the document types in the system. So if we open location, and this is auto-generated, so this is not something you normally look at, but this contains all the properties of that definition of a document type. And using this definition, you get strongly typed access to all content in the system. So this was the starting point for when we want to start to implement OData. And our goals for implementing OData was that we want to fully support it, so we could take full advantage of all the tools in the market and the whole ecosystem. And it had to be built on top of the API, so we could maintain the access rights to content in the system. And we want to use the libraries available and minimize our own custom code. We're a fairly small company, so we don't have several man-years to put on the project, and it had to be a good solution, but it couldn't involve too much work either. And it had to work for not only the text in the system, but we also had to find a good way to work with, for example, files in the system, images and videos and so on. And it had to be quick to get up and running. It shouldn't involve lots of configuration and so on to just get an OData endpoint up using an existing Webnodes site. So some of the challenges we had was that the existing object model is way too complex to expose as is. One of the problems is inheritance. We use it a lot. And we have a lot of complex property types. For example, the file property has 6 or 7 data values that make up the property. So the conclusion to that was that we couldn't use the existing object model. We also determined that we need to control what we exposed in OData. So we could just expose a part of the content in the solution, not everything. And we also wanted to make a separation between the naming of the properties and so on and classes in our internal object model and the ones used in OData. The solution we came up with was that we generate a new OData-specific object model on top of the existing API. We use the code generation technology that we already use in the existing system to generate a new object model. We then just expose iQueryable for each of those new classes in the OData object model. We have created some helper properties to minimize the amount of data you have to transfer. In version 2 of OData, there are some limitations there, and you also want to minimize the number of calls you have to make to the OData endpoint. And since we're generating the new object model on top of the existing one, we maintain the access rights. So all access to the OData endpoint is filtered on access rights. So I'm going to show that later. And it's very easy to set up. And it's easy. We found a way to make it really easy to use non-textual content as well. And I'm going to demo all this quickly. I'm going to show you how to set up an OData endpoint. I'll show you the generated object model, demonstrate that access rights works, and how you can work with files in the system. Okay. First of all, I'm going to set up an OData endpoint. We're going to the system module here and go to the installation settings. Here we have an own OData tab. So it's just to say I want to enable the OData endpoint. We have some different options here. The URL we want to expose the endpoint on. If you want to allow write to the endpoint, read access, write access, and so on. And if you want to impersonate an existing user in the system for those that are accessing the OData endpoint. And if you want to expose all types and all properties, or just the ones you mark as exposable in the object model. For now, I'm going to just expose everything. So now I've changed the settings, but we still have to generate the object model. So then we go to the ontology module again. And by doing a full rebuild, it loads the latest definition of the ontology and builds the new object model. So we're going to do that now. That takes a few seconds, but it's mostly the startup that takes time due to the slow PC. But yeah. Are there any questions so far? Yeah?
Have you done any GIS-enabled data?
Okay. If we have done any GIS-enabled data, and we haven't so far. But one thing to remember is that we're a very general solution. So we can't specialize on one type of solution. We have to make something that works for as many cases as possible. So we can't spend too much time on one area. Okay, now it's starting up again. That takes a few seconds.
So for this part that you're demonstrating, it's all your own runtime, your own development runtime code that's doing this?
Yeah.
Yeah. Okay.
So it basically just generates some C# classes on the disk and restarts the web application. Okay, now we're back up and running. And if we go to the URL that we said we wanted the OData endpoint, is OData Meetup. And here we get the OData endpoint. We can also connect using, for example, LinkPad. We can say locations. Okay. Sorry. Okay, so here you see that we can connect from LinkPad as well. If we go into the Visual Studio project now, we can see that we have the OData service file here. And here you can see this is 5,500 lines of code that recreates the object model in OData-friendly format. And here you can see we're mapping up the atom properties and so on. So if we go to just to demonstrate that it finds stuff, you can just say you want locations, and here you can see it interprets the result as a feed. Okay. So I've shown you the generated object model, but let's take a look at some access rights as well. So from L in locations, select new. Okay. Now you can see there are 12 cities in the OData endpoint. But if we go to the system here and go to the content module, where you have all the content in the system, you can then just, for example, edit one of the cities. So this is how the edit interface for a normal user looks like. You can preview the content, for example, by opening that. But if we just go to options and change the read access to the content, here you can see it's for everyone at the moment. But this, if we change this to, for example, okay, we changed it to system user. That basically means that any user that's logged in at all. So that means that it shouldn't be available to anonymous users. So if we run the same query here, you can see that we get 11 results. So the results has been filtered based on access rights. But sometimes you want to make sure that the OData endpoint can impersonate another user, so it can have more than anonymous access. So we can go into the system module and say that we want the OData endpoint to impersonate the user. I know there's a user with ID 371. So if we go back here, now it's 12 again. So there are many ways to work with access rights in the system. These were just 2 of them, but there are more. Okay, then let's go back to the presentation. Okay, working with files was the last one I forgot. If we go to the website itself, or we can go to LinkPad just to demonstrate. If you see here, you see that the top picture, that is basically just the URL to the file in the system. But that's the original file in the system, and if you want to use our content in your website, for example, you don't want the original image, and if you don't have a way to change the size of the image coming from us, you have to manually store it on your server and then convert it there, and that's much more heavy process. But we have a system that makes it really easy to change by just changing the URL. So here we take the URL from the OData endpoint. If we paste this into the browser, you can see this is a fairly high resolution image. By just adding adjust equals 1, and say, for example, x equals 500 and corner equals 150, we get back a different version of the image with rounded corners. And what you have at the end here is everything that the consumer of the OData endpoint has to add to the URL to get a different version of the image. Our server scales and returns the scaled image. So that's a really nice way to work with the OData and files in OData. Okay, a quick case study before we round up. The Association for Norwegian Architects in Norway, they have a department called EcoBox. They have a project database about eco-friendly building projects in Norway. They have built up that database over many years, and multiple government institutions want to use that database and show the data on their own websites. So what they have done is to expose all the projects as OData, and the Norwegian State Housing Bank is then using that data and displaying it in real time on their own site. So we can just quickly demonstrate that. So all of the projects you see here, that's fetched from another Webnodes site in real time. And if we go into a project, this wasn't a good example, but the files and the images you see here are fetched from our server using the same URL stuff I just demonstrated. And for a normal user, he wouldn't know that this is actually content from another server located in another server facility. So if we go to this is the main site where the projects live as normal web pages as well. So here is EcoBox, and here is the project database. So here you can also see the same projects in a different template and so on, but this is using our native API and not OData, but you can see that this is exactly the same. Okay. So the State Housing Bank is already using it. The Ministry of the Environment is in the process of connecting to the endpoint. They also have the 13 largest cities in Norway going to connect to the endpoint. And also Enova, which is about energy efficient heating. They hand out grants to private persons and companies that are building houses with energy efficient heating solutions. Are also going to connect now before the summer, and there are already 2 other departments or organizations lining up to join the same endpoint. So to summarize some of our experiences is that OData is really simple to use. And when a new partner wants to connect to one of our endpoints, it's basically no work for us. We can just point them to odata.org. But what I haven't seen today is that in all the projects we've done with OData is that we get requests from the developers that don't know anything about OData. They wonder, how can we search the OData endpoint? That is something maybe one should have some more opinions about and talk more about. Maybe it doesn't fit with OData, but at least for people that aren't familiar with OData, that is something we see that many are wondering about. We can solve it today with service operations, but it's more like that's custom work, and we would like to have a standardized method of doing it. Query capabilities have been the biggest problem so far. Since we're doing real-time integrations, it has to be really performant, and without any and all, that's a big problem today, because you want to query exactly the data you want to display, and today you have the choice of either fetching more data than you want or making multiple calls to the OData endpoint, and neither is really ideal. So we're really looking forward to version 3. Tool support is also important, not just for the development phase, but also to sell in the idea of OData and Excel and the Power Pivot plugin, for example. When we can show that you can import all the data from a CMS directly into Excel and create charts and so on based on the data there. That's a killer feature for non-technical people, at least. Many .NET developers use LINQ when they're writing queries for OData, and that's really nice, but there's quite a bit of frustration that they can write a LINQ query and run it and it fails. So the more of LINQ that's supported, the better. We also have multiple partners asking for reporting services to consume the data, not just expose the finished reports as OData. LinkPad is very valuable, and lots of our partners are using it in the projects. And it has been mentioned by several others so far, but the client libraries for as many platforms as possible is really important. Because if we want to sell the ID to OData to partners, and especially government organizations, it has to be as open as possible. And you can't sell a solution that's limited to just a few platforms. So this is Save the Children Foundation in Norway. They're using the Power Pivot plugin in Excel to generate the real-time statistics based on the e-commerce solution in our CMS. They can just send out the Excel file to different people in the organization. They can just click refresh in Excel and get up-to-date results without even knowing about the CMS at all. Some of the future plans we have is that we want to support multiple endpoints. Today we can limit the people that can access what content and so on. We have access rights to the content, but we also have access right on properties, for example. So we can limit that a certain user group can't access the content in a property, but since the property is in the OData object model, it will see the property, but it won't access the content. But that's confusing, so we want to support multiple endpoints where you can specify the endpoint to suit each user group. And you can then, of course, also have different settings and access rights on each endpoint. We're going to do vocabulary mapping between OData vocabularies and the internal ontology. We already have scheme.org mapping. Just a quick look at that. If we go to definition module here, and if we take a look at recipe, for example, you see we have a microdata tab here. Here you can search the whole scheme.org vocabulary and map up that against our internal ontology. So, for example, if we want to say, here you see all the different scheme.org entity types. So this is something similar we would like to do with OData. Content negotiation. I'm not sure how many are familiar with that term, but DBpedia, for example, has the content negotiation. So you can have the same content available in different formats. So we have HTML already. We have OData. We're going to support RDF before the summer. We're going to support CSV and PDF as well. And so by just changing the URL, you can get the same content represented in different formats, but in a very easy and consistent way. We're planning an automatic edit interface for OData endpoints, so we can connect to external OData endpoints and produce the same edit interface that we have seen so far on the external data endpoint. So we can then have a nice GUI on top of the OData endpoint. And we think that it's becoming more important to bring different data sources into the same solution. And we also want to add more support to consume content from other data endpoints in different ways. But I don't have time to go into details there, but that's something we're looking at. One small wish for the future of OData is to investigate if JSON LD could be supported, and that's JSON for linked data. We strongly believe that semantic technologies and so on will be an important part of the future, and vocabulary is a big step for OData in that regard, but JSON LD should also be a fairly low-hanging fruit to support. So I think that's something that should be investigated, at least if it hasn't been already. Okay, that was everything. If you have any questions or comments, email me or contact me on Twitter or whatever. So, any questions? Yeah?
A question on content negotiation.
Yeah?
Could you describe, well, I don't know how to best put this, the OData endpoint? I'm assuming, OData, Atom, and JSON are emitted from one URI, where you have content negotiation based in the header.
Yeah.
Are you using a different endpoint to emit, say, HTML, RDF, etc., or is it all in the same URI using true content negotiation in the header between those?
He's wondering how we're planning to do the content negotiation with OData, because today we have one endpoint where we expose the OData, but in content negotiation you would have one URL, and by just adding something to the URL you can change the format. So that's a different way from what we're having now, but it hasn't been decided yet. We're looking at different alternatives on how to do that, but I don't think that's going to be a big problem, basically. We control the whole spectrum of technologies here, so yeah, we have some demos up and running in the lab already. So, but it has to work with all the other formats as well, so it's important that we... So I won't comment on exactly on what we want to choose yet.
So could I just follow on that? Not what you're going to do, but say what you would prefer to do. You mentioned adding something to the URL to describe the content.
Yeah.
For example, like a $sign format, is that?
Yeah, something similar to that.
So we use that, or preferably accept header content negotiation.
Yeah, probably
right?
both, I guess. So
that aside, would you prefer that all your content is emitted on the same URI, modulo the query string or the header, or regardless of, behind the scenes, maybe you have to manage multiple different servers, and this is my OData server, this is my web server, this is my other server, but you're going to do some kind of URI mapping, right? But is it your objective to keep the same content coming from the same URI, regardless of its content type?
Yes. To summarize the question quickly, he wonders if we want to maintain one URI for all the content, no matter where the content is coming from, and yes, that's what we're aiming for. So hopefully we will manage it.
Don't make that too easy.
Yeah. So, but we'll see. But maybe next year we'll see if we have a solution. So, okay, thank you.